day, ladies and gents. All right, so today is day 2 of quadrilateral notes. So a couple of things you guys should have. You should have 2 different color utensils, or maybe a pen, maybe red pen and a pencil. That would be wonderful. You definitely need a calculator. You want that too. And of course, you want your pages out. So let's get this started. All right, so starting on page 1, these are our notes. So on page 1, we just need to go over a couple of things. So parallelograms. Okay, interesting enough, parallelograms are quadrilaterals that have parallel sides. So there's a couple of rules you need to know, and don't worry, you get to use this on your test probably. Just fake it till you make it. It actually does make sense. So first of all, parallelograms. So parallelograms, opposite sides are parallel. So this side and this side are parallel, and this side and this side are parallel. So that's very important. And your best friend is alternate angles. Basically, when you have a line that goes across, you can do a Z. So the Z is alternate angles. So the inside corners would be equal to each other. So in this case, this diagonal goes here, so I would have to turn my paper this way, and then these two angles, this angle right here and this angle right here, would be equal to each other. So that's very important. And the same thing going this way, these two angles would be equal to each other. This angle right here and this angle right here. So there's multiple ways of how to look at that. So if you can do a Z where the top and the bottom of the Z are the parallel sides, then the inside corners would be equal to each other. So that's the first thing. Opposite sides are parallel. Also, opposite sides are congruent. So these two sides are equal to each other, and these two sides are equal to each other. Okay, the next rule is opposite angles are congruent. So these two angles are equal, and then these two angles are equal. So a second set of angles are equal to each other. Consecutive angles are supplementary. So these two angles add up to 180. Or these two add up to 180. Or these two add up to 180. Or these two add up to 180. So consecutive angles. So consecutive angles are supplementary. So consecutive means that they're next to each other. Or same side. So if they're both on the same side of a quadrilateral, then they add up to 180. Very good. Now there's some other rules. So if one angle is 90 degrees, then they're all going to be 90 degrees, which would make it into a rectangle, or if all the sides are equal as well, then it'd make it into a square. But if one angle is 90, then they are all 90 degrees. Okay, diagonals bisect each other, so they cut each other in half. So this side, so these two would be equal to each other, and then a second set, these two would be equal to each other. So if this was 9, this would be 9. If this was 8, this would be 8. Okay, so just pointing that out. Okay, and then diagonals create two congruent triangles. So this triangle will be equal to this triangle, and it feels like it rotates. So notice that A is equal to C, and B is equal to D on this triangle. And this. So if I go open, closed, empty, because that's how I'm describing those little dots, then you would do the same pattern: open, closed, empty, and you would do the same thing over here. So just be mindful of that. All right, so right now you're just accepting stuff. No worries. Okay, let's go ahead and go to page 2. So on page 2, so notice we haven't written really anything down. I already did everything for you. Okay, so a rectangle, here are all the rules. So first of all the parallelogram rules that we just said a second ago still all apply. So all those rules are true. In addition to that, here are the 3 extra rules you need to know for a rectangle. So very important that you remember these 3 extra rules. First of all the interior angles are 90 degrees. So that's the first rule. That's the first main rule for a rectangle. All 4 angles are 90 degrees. The other rule is diagonals are congruent. So if all of this is 10, all of this would also be 10. So the diagonals are congruent. And finally, all the diagonal parts are congruent. So if this is 10, so all of these are congruent. So this would be 5, 5, 5, and 5. So these two kind of basically are the same idea. So basically you feel like you're only doing 2 rules, but 3 rules are fine. Okay, so all the interior angles are 90 degrees and all the diagonal parts are equal. So all 4 of these are equal to each other. Simple as that. Okay, now a rhombus. So a rhombus basically is a square knocked over. So a square knocked over. So just keep that in mind. A parallelogram that we just had was basically a rectangle knocked over. So just keep that in mind. Okay, so a rhombus is a square that's knocked over. So all the parallelogram rules still apply, and in addition to that, there's 3 extra rules. All the sides are congruent, which makes sense because it was originally a square and it got knocked over. So all 4 sides are congruent. The diagonals are perpendicular, so in the middle are 90-degree angles. And finally, the diagonals bisect each other. So so these 4 would be equal to each other, and these 4 would be equal to each other. So basically, just keep this in mind. If this right here was, if this was 20 degrees, then this would be 20 degrees, that's 20 degrees, that's 20 degrees. And we also know that these are 90 degrees. So if we had 20 and 90, what's left over for this top angle? That would have to be 60 degrees. Nope, 70 degrees. Math. So that would have to be 70 degrees to complete the 180 degrees in that one triangle. So 90, 70, and 20 make 180. So this would be 70, this would be 70, this would be 70, and this would be 70. And in addition to that, all of this was 40, it got cut in half. All of that was 40, it got cut in half. All this would be 140, all of this would be 140. Isn't that nice? Okay, so those are the basic rules for those quadrilaterals. And then finally, the square. The square is the perfection of all of these. So interesting enough, all 4 sides are equal. All 4 angles are 90 degrees. So basically all the rules we just said apply to this. So all the parallelogram rules are still there. But in addition to that, all the rectangle rules and all the rhombus rules are in there. So in the middle, these are all 90 degrees. We also know that all 4 of these would be equal to each other. And then we know that these are angle bisectors because that's the rule of a rhombus. So if this was already 90 degrees, which is a rule of a rectangle, and this got cut in half, rule of a rhombus, then this would have to be 45 and 45, and so on and so forth. Okay, so there's that. All right, let's go to page 3. So on page 3, there's some additional rules that you're just going to have to memorize. They kind of make sense. Just go with it. So these right here, these rules right there, those are things that you just need to be mindful of. It'd be really nice to read right before you take the test. It's just one of those true-false kind of things you need to know. All right, so these 5 additional ways to prove that a quadrilateral is a parallelogram. So first of all, if both pairs of opposite sides are parallel, then there's the quadrilateral is parallelogram. So if these 2 are parallel and these 2 are parallel, it's a parallelogram. Simple as that. If both pairs of opposite sides are congruent, so if both of these are congruent and both of these are congruent, it's a parallelogram. It might be a rectangle, I don't know, but at the very least, it's a parallelogram. If both pairs of opposite angles are congruent, so if these 2 are equal and these 2 are equal, it's a parallelogram. And then if the diagonals bisect each other, so if these 2 are equal and these 2 are equal, then it's parallelogram. So basically, these are the rules that you were kind of already memorizing in the first place, which are these rules down here, right? Okay. So this one is the important one because it kind of stands out. This is not one of the rules. This one's not one of the rules up here, but this is an extra one right there. So if one pair of sides is congruent and parallel, so if this one pair of sides, it's both parallel and congruent, then it's also a parallelogram. So that one stands out. That's not one of the rules. That's just a way to prove it's parallelogram. It stands out. So just be mindful of that. Okay, number 20. So I grabbed this out of a true-false list of things. Okay, so for this right here, you need to be mindful of if you can think of one counter example, then it's false. So it's easier to disprove things than to prove it, right? So if you can think of one counterexample, it's automatically false. So I like to draw pictures exaggerated, and then I'll have a good idea if this is true or false. Okay, so a rhombus has four sides that are congruent. Okay, now first of all, I know for a fact that that is a rule because a rhombus is a knocked over square. That was the defining rule of it. All four sides, so all sides are congruent. So I know for a fact that that's true. So that's a defining thing. It's a knocked over square, and a square has all four sides are equal, right? Okay, a rectangle where all four congruent angles. So, well, that's another defining thing because all the angles are supposed to be 90. So that's an actual rule. So that's true. Okay, diagonals of a rectangle bisect opposite angles. I don't remember that. So what I'm going to do is I'm going to draw a super exaggerated picture of this and try to be as accurate as possible. So exaggerated picture, I'm drawing it super long. See, that's me exaggerating that. And then the best thing I could do is to grab my ID or a straight edge of some sort and just make the diagonals, right? So trying to be as exact as possible. So there's a diagonal. And here's the other diagonal. So trying to be as exact as possible. Now the diagonals of the rectangle bisect the opposite angle. So we're trying to say that these two were bisected, right? So this angle right here was bisected. Does this even look like this angle up here is equal to this angle down here? Does that look the same? Does it look like it got cut in half? No. You can really tell this by the exaggerated picture. If I just drew this rectangle right here, it's really hard to tell if this and this are equal to each other or not. This I can really tell. So I've made the exaggerated picture. This is my counterexample, so that is super false. Okay, and the diagonals of a rhombus are always congruent. Okay, let's see. If I made an exaggerated picture of a rhombus, so basically I flatten it as much as possible, and I make the sides equal to each other. Okay, so this diagonal and this diagonal. Do they look like this is equal to that? No. So this looks like this is, I don't know, this is 4, and this looks like this is 7. So I don't know. I'm just making stuff up, right? So, but these do not look like the same distance, so that sucker is false. Okay, so we're going to keep this next to us, all these little rules next to us while we do this. And even if you can remember it, it'd be nice to just have exaggerated pictures. So we're going to skip page 4, and so we're going to skip a bunch of these pages because we've either done them already or we're going to do them later, and we're going to go straight to page 11. We're going straight to page 11. So we're going straight to page 11, and we're going to keep these rules out in front of us while we do them. Okay, so we're on page 11. We're on page 11. So properties of a parallelogram. So I still have my page 1 in front of me. Here's parallelogram, and here are all of the rules. Okay, so opposite sides are, now we can do this out of order. It doesn't matter because opposite sides are two different things, obviously. So opposite sides are parallel, and opposite sides are congruent. And I'm just going down the list that it says right here on page 1. Okay, the third rule was opposite angles. Opposite angles are congruent. Consecutive angles are supplementary, meaning that they add up to 180 degrees. And diagonals bisect each other. They bisect each other. So one of the best things I can do, if I cannot remember all these rules, what you can do is draw an exaggerated picture. Now, parallelogram is a knocked over rectangle. So I'm just going to try to draw this as accurate as possible. So, and I'm going to knock it over as much as possible. Let's see. And so I'm mindful of, I made it this distance right there. And then, so I have a little line right there, and I'm going to make that same distance right here. And I'm just going to connect those two dots. Okay, so that looks basically the same, right? Okay, so, and then I'm going to make my diagonals. So I'm just making an exaggerated picture off to the side, just in case I can't remember all the rules. If I look at this picture, I probably have a good idea of what's going to happen. So for instance, I know for a fact that these two are definitely not equal, and that these do not make 90 degrees. But I do know that this angle right here does look like the same angle right there. So I can make a Z thing. So this is just, if I can't remember the rules, I can probably fake it by looking at this exaggerated picture that I just made. All right, so number one. Okay, now this is where I said that you should probably use two different colors. If you are not doing this on a piece of paper, if you're not doing it on the worksheet and you're doing it on a different sheet of paper, I suggest you make this picture super big, or you are going to draw this picture twice, one for the sides and one for the angles. So you do what works for you. Okay, so I am going to go ahead and use pencil. So I'm going to use pencil for all my sides. And I'm going to use pen for all of my angles. And notice I put a key here. That would be nice to remember. Okay, so sides. Okay, so x to y is 15. And z to x. So z to x. So that's all of this distance. So all that distance, and it ends right here. So I'm going to put 52 right here. And I'm putting it in the direction that I was going. So that's one thing. Okay, and then, and let's see, what else? We have WXT. So this is the angle. So so I'm at X. So the angle is going to be right here. So I'm at X, I'm pointing towards W and T. So WXT, so that would be right here, is 35. And maybe you just want to circle that. That would be another thing you can do to try to keep it different. If you're doing it all on one utensil, then maybe all of your angles are going to be in circles. That way they won't run into each other. So that's just an idea. So you do whatever works for you. And they also said that I'm at W. So I'm at W right here. So Z, W, T. So that would be, I'm at W, I'm pointing towards Z and T. So that would be 59 goes right here. Okay, so now let's go ahead and look at the sides. Okay, if this is 15, then I know opposite sides are equal to each other, so 15 would be over here as well. And let's see, they also gave it to me the other side, the 52. I know for a fact that this sucker got cut in half. So if this was 52, divide that by 2. So 52 divided by 2, I know that this is 26 and this is 26. So those two are 26. And can I find this? Well, this is not a right triangle. It's not right, so I can't do Pythagorean theorem or anything, so I'm probably stuck. So let's see. They asked me for these sides. Let's see if I found them. TX, T to X. Oh, good. That was 26. Oh, I forgot ZW. Z to W. Oh, good. 15. And that's all they wanted. Fantastic. All right, now let's look at the angles. Okay, so they want TZY. So so I'm at Z, so TZY. So I want this angle. Okay, I know for a fact I can do the Z thing. So if I make a Z, oh look, there you go. So this is 35, and down here would be also 35. Isn't that nice? So 35. And then I'm at Y. They also wanted X, Y, T. So they want this angle. And what would that angle be? Let's see. Can I make the Z thing, the alternate interior angles? Oh, look, here we go. Here's a Z right here. Oh, good. The other inside corner would be 59. So this is 59. And so we found those. Isn't that nice? Okay, so hopefully you notice that you want, if you're drawing this on a substitute paper, you want to draw this picture nice and large so you can write stuff in it and it won't overlap each other, because 26 and 35, if this was a small picture, they would run into each other. You couldn't tell what goes to what. Also, different colors help. circling all of our angles really helped. Just be mindful, figure out what works for you, find the things that do not work, and fix it. Okay, so we have those answers right there. Go down to number 3. All right, so on number 3, we're talking about rectangles. Awesome. So let's get out the notes about rectangles. So if we get out our notes on rectangles, so that's page 2. So all the parallelogram rules are true, and in addition to that, we have these extra rules right here. So that's on page 2. So rectangle rules, all the parallelogram rules are true, and these extra rules right there. Okay, so keeping that in mind, another thing you can do is if you cannot memorize those rules, a wonderful thing to do is draw an exaggerated picture. So I'm going to take a straight edge, and I'm going to make a distance. And I'm making sure like it's going to be this long kind of thing, right? So I'm keeping that in mind, and then just keeping it exaggerated. Okay, and then connect the make the diagonals. Okay, so not the best picture in the world, but it's pretty accurate. And I know for a fact that all of these are equal. Okay, so just to keep that in mind, right? Okay, so having this exaggerated picture, I know that these are 90. I know this and this are definitely not equal, but it does look like this and this are equal, which does make sense because it is an isosceles triangle. So just pointing some random stuff out. All right, so number 3, keeping in mind about this right here. Okay, so they said one of the sides, so I'm keeping with it that the sides I'm going to do in pencil and the angles I'm going to do in red. All right, D to B. Okay, that is the whole shebang, so I'll write this out here. So 42. And I know that this sucker is going to get cut in half at the very least. So 42 divided by 2, I get 21. Because in the very least, it is a parallelogram. Oh, but wait, it's a rectangle. All 4 of these are equal. So this would also be 21. This would also be 21. Isn't that nice? Okay, they also said A to D. So A to D is 26. So this is 26. Hey, great. This would also be 26 over here. Would this be 26 over here? No. This would not be 26 up here. Okay? Because it's a rectangle. These would be equal, but these would be equal as well, but they're not equal to each other. So just pointing that out right there. Okay, they also said angle-wise that angle A, so I'm right here, but the question is, am I at the top, the bottom, or the whole shebang? So DAE. So I'm at A, I'm pointing towards D, and I'm pointing towards E, so that's just the bottom. So that is 42. So it's 42 degrees. Okay, so I know that because these two are equal, so if my arms are equal, so if I turn this, if my arms are equal, then my elbows are equal. So this would also be 42. Right? Okay, and then I also know that this sucker is 90 degrees all over it. So if that's 90 degrees completely, then if this was 42 down here, then this would have to be 48 right here. And this is 48, and this is 42. I know I can do the Z thing, right? This would be 42. The Z thing, I can do that. This would be 48. This would be 48. We could also go even a further step. If this is 48 and 48, what's left over right there? So 180 minus 48 and 48, I'd be left with 84. There's 84 here. There'll be 84 down here. What'd be left here? So 180 minus the 42 and the 42, I would get 96. Or I could have completed the rainbow of a straight line. So if this is 84, this would have to be 96 to complete 180 degrees. So many possibilities. Okay, so I went crazy with all the possibilities I could see. So let's narrow this down a little bit. A to C, so that entire distance would have been 42. E to B, here's E, here's B, right there. E to B, that would be 21. Excellent. They also wanted angle D. So here's D. I don't know if I want the top, the bottom, or the whole shebang. I'm at D, and I'm pointing at A and C. Oh, A and C. Okay, that is the whole shebang, and that is 90 degrees. And they also want an angle E. Ooh, E. All right, so E, I'm either talking about the top, the bottom, the left, or right, the whole shebang on certain different things. So many possibilities. So I'm at E. I'm pointing towards D and C. So they only wanted the bottom angle. So at E, pointing at D and C, that's 84. So you probably want to backtrack on number 3, watch that over again. The second time you watch that, it will make more sense. The first time I did that, your head probably exploded. So don't worry. I've just done this a lot. Okay, now number 4. All right, so so they said sidewise. They said V to W. That's just this little one. That is 9x minus 11. And they said S to U. That's the whole shebang. So that's 16x minus 12. Okay, so with that, I know that this is a rectangle. So all 4 of these are going to be equal. So this would be 9x minus 11. This is 9x minus 11. This is 9x minus 11. And look at that. I know this plus this equals the whole shebang. So 9x minus 11 plus 9x minus 11 equals the whole shebang, 16x minus 12. Okay, and just solve. 9x plus 9x is 18x. Negative 11 minus 11 is negative 22 equals 16x minus 12. Okay, so we're going to do 18 or minus 16 from both sides. We get 2x equals. I'm going to add 22 to both sides. So negative 12 plus 22, I get 10. And x would equal 5. So I just took this and solved and got 5. And what did I train you to do after that? Always plug it back in. 9 times 5 minus 11. This would turn into a 34. That would also be 34. And here it should be 68. Let's check. 16 times 5 minus 12. Oh, good. I do get 68. This does check out. Okay. Always your final step is to answer their question. They wanted W to T. All right. So these disappeared, and this turned into a 34, 34, 34, 34. And they wanted W to T, which is right here. And that was 34. So 34 is our answer. All right, you guys are doing great. I'm hoping. All right, let's go to number 12. So page 12, we're on page 12. So page 12, we're on rhombuses. So rhombi. Okay, so page 12, we have all those rules. And feel free to draw an exaggerated picture where it just fell over. So I'm just going to draw a square that knocked over. So okay, we got this. Nice. Okay, so I'm trying to knock that over as much as possible. And then bump, bump. All right, so we should have a nice idea with this. So I know that all these are 90 degrees. I know this and this, this and this are, all 4 of those are equal. And I know this and this, this and this are equal. Okay, so with that idea, let's go ahead and go through our rules. Using these rules right there, you can read them yourselves. Let's go ahead and do some problems. Okay, so in pencil, here are the sides. So ZY is 34. And they said WY, that's the whole shebang, is 38. So if the whole shebang right there is 38, then when you cut it in half, so 38 divided by 2, this would be 19, this would be 19. Okay, now this is not a rectangle, so all 4 of these are not 19. This is not a rectangle. Okay, and then they said for angles, so I'll zoom in here. They said for angles, angle X, so I'm at X, and I'm pointing towards Z and Y. So Z, X, Y. So that'd be this angle right here is 34. Okay, at the very least, I know I can do a Z. So right there, this will also be 34. Isn't that nice? But because it is a rhombus, I know that all of these are 34. And right here is 90, 90, 90, and 90. Okay, let's see what they even want in the first place. They wanted W to Z, so they want this sucker right there. Isn't that just great? Okay, well, let's think about this. A rhombus is a square knocked over. So if I have one outside, I actually have all four. So if this is 34, that's 34, that's 34, and that's 34. Fantastic. WZ is 34. Okay, ZV, so that's this sucker. Well, great. I have this side is 19, this is 34. Hey, look, that's a right triangle. Okay, so with a right triangle, if this right here is 19 and this is 34, I'm looking for this. You put your finger on the right angle, the two sides you're touching are A and B, it doesn't matter which one's which, and the one side you're not touching, the biggest side is C. So we have x squared plus 19 squared equals 34 squared. Okay, x squared, so 19 squared, we get 361 equals 34 squared, which is 1156. I ran out of room, so I'll put it up here. I'm going to subtract 361 from both sides. I get 795. We're going to square root both sides. And we get approximately 28.2. Approximately. So here was, so the square root of 795. And you get this answer. So is it 0.1, or are we staying at 0.1, or are we going up to 0.2? So look at the number after it, that would maybe go up to 0.2. So roughly. All right, so this right here would be 28.2. And this would be 28.2. So 28.2 is your answer. Okay, now let's look at our angles. They want angle V. Well, this should be really easy. Every angle at V is 90 degrees, but let's make sure it's not 100, 180, or 270. Let's figure out what they want. They wanted W, V, Z. So that we're at V, we're pointing towards W and Z, so that means 90 degrees. Perfect. All right, let's keep going. So we could have found these other angles, but they didn't even ask for it, so why bother? Okay, number 6. So we're almost done, guys. All right, so we have, we know it's rhombus, right? So we know that this is all these are 90 degrees. So with these angles right here, I know for a fact that the 3 angles of a triangle add up to 180 degrees. So let's just bust it out. I know 7x minus 1 plus 4x plus 3 plus 90 adds up to 180. So the 3 angles of a triangle add up to 180. 7 and 4 and nothing make 11x. Negative 1, a positive 3, and a positive 90 make 92 equals 180. So 180 minus 92, we get 88. Divide by 11, and we get 8. Now, I've trained you, every time that you find x, always plug it back in for a number of reasons. One, to double check yourself. Because if you get a negative number, you know something's super wrong. And also to help you answer any question they ask. So if we plug this back in to the original, so 7 times 8 minus 1, this would be 55. And then 4 times 8 plus 3, we get 35. And this is still 90. So 55, 35, and 90 do make 180 degrees. So we can put that back in there if we like, depending on what they're looking for. So this would be 55 right here. And this right here was 35. All right, let's see what they were asking for. They wanted HGI. So we're at G. Oh, so we have to go all the way over here. We're at G. We're pointing towards H and I. So they want this angle right there. Okay, so I know I can do a Z thing. Oh, look at that. There it is. It's 35. So that's 35. So 35 was our answer. All right. Okay, last 2 problems. Here we go. Okay, square. A square. So we're going to be looking at our rules for a square. We're going to be looking at our rules for a square. Okay, so even before I start, they said that the side length for A to D was 11. So that means all of these are 11. Isn't that nice? Okay, but the angles are like the super easiest thing I could possibly do. I know that all of these are 45. And I also know that all of these are 90. Just because I'm lazy. Okay, so let's find the angles. So I'm at A. Okay, so D, I'm pointing at D and B. Okay, so that is the entire angle. So DAB, so that's 90 degrees. Angle C, CBD, so I'm at B, so B right there, CBD, so that's just this little angle right there, which is 45 degrees. So the angle at B pointing in that direction, so that's just 45 degrees. Okay, so the angles are really fast. A to C, that's the whole shebang. Let's ignore that for a second. B to C, okay, that's an easy one. That's 11. Okay, so the only question is, what's A to C? So they want all of that. Okay, easiest thing to do, we have a right triangle. This is 11, that's 11, and I'm looking for this. Okay, so A squared plus B squared equals C squared. So put your finger on the 9 degrees. The two sides you're touching are A and B. The one side you're not touching is C. That's always the longest side. That's x squared. So we get 121 plus 121 equals x squared. That's 242 equals x squared. Square both sides. So the square root of 242, we pop out with approximately 15.56, blah, 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 blah. So about 15.6. So now if they were asking for this little thing, I would use this big long decimal before I would divide, but we don't care right now. So it's 15.6 is your answer because they wanted the whole shebang. So 15.6, and they specifically said round to nearest tenth. All right, so how many zeros does 10 have? 1. So we're only going one decimal place. The question is, are we staying at 0.5 or going up to 0.6? 0.6. Okay, last problem. Okay, number 8. All right, so on number 8, they said that SW is 2x plus 13, and WU is 8x minus 41. Oh, that's pretty easy. All of these were equal. So 2x plus 13 equals 8x minus 41. We get 13 is equal to 6x minus 41. Add 41 to both sides. We get 54 equals 6x. Divide by 6. 9 equals x. And I've taught you to always plug it back in for multiple reasons. One, to check yourself, and also to answer any questions they ask. So 2 times 9 plus 13, this should turn into a 31. 8 times 9 minus 41. Oh, good. That would also be 31. So this disappears. That's 31. This is 31. Hey, guess what? That would be 31. That would be 31. And let's see what they wanted. V to T. V to T. Ooh, that's the whole shebang. And that's over here. So if this is 31 and 31, what's the whole shebang? 62. So 62 was your answer. Okay, so now it is your job for the rest of this is to go back and do page 9 and also to do page 13 and 14. And that's what you guys are doing. Other than that, have a great and wonderful day. As soon as I find my mouse.